Hello students, welcome to NEET CT Mentors channel. Today's topic is current electricity. We are discussing the PYQs on the current electricity chapter, and we have collected expected questions for the 2025, and we will be solving those in this session. Do solve with us simultaneously. Have a pen and paper and note down the formulas that are mentioning here. Okay, let's start. First question: 10 resistance R are connected in a series to a battery of EMF E and a negligible internal resistance. Then those are connected in a parallel to the same battery. The current is increased n times. The value of n is. Yes, it is a topic based on the series and parallel question. Okay. See, first initially what they are telling the 10 resistors, equal resistance connected in a series. After that, they will do, they will connect those same in the parallel. Then current increased by n times. The main important point, that is resistance in series will be going to add summation, but in parallel, when it comes to parallel, it will be added by a 1 by R plus 1 by R2 plus 1 by R3. So the automatically the parallel value of the resistance is lesser than the series resistance. So let me explain you. In series what happens, see, in series Rs is equal to R1 plus R2 plus R3, right? R1 plus R2 plus R3. Same on R, but in parallel what happens? That is 1 by R1 plus 1 by R2. If this is the case, the resistance always, if at all the same data is given, resistance always greater than the parallel. But asking this ratio, how much will be the ratio? So, in that particular question, there are 10 resistance. Okay, so series R series is equal to, that is R plus R plus R plus so on till the end R. So the answer is for 10R. The same if applicable for R parallel, it is Rp is equal to, it is 1 by R plus 1 by R plus 1 by R so on. If you do that, then the answer will be 10 by R, right? Finally they are asking how much times the series resistance compared to the parallel. That means the easy way to find that is just divide it, divide the Rs by Rp. If you divide those two values, then you will be getting, how much times is that, right? See, sorry, this is 1 by Rp. 10 by R is not a Rp value, this is 1 by Rp value, right? Because 1 by Rp is equal to 1 by R1 plus 1 by R2. Like that, if you do Rp, you will be getting, that is R by 10. You have Rp as R by 10, you have Rs as a 10R. Then the ratio of them will be giving how much times the series resistance is greater than the parallel resistance. So Rs by Rp is equal to 10R by R by 10, right? If it is so, R and R going to divide, we will be getting 100, right? Moving on to the next question. Second question. A set of n equal resistors of a value R each are connected in a series to a battery of EMF E and internal resistance R. The current drawn is I. Now, n resistors are connected in a parallel to the same battery. then current drawn from the battery becomes 10I. The value of n is, the value of n they are asking. You know, for this equation, that is when the EMF E, when the terms that are EMF E and number of resistance n and internal resistance, that is here given as a capital R, and also normal resistance that is also given as a capital M. If these all terms are included and they are talking about the series and parallel with that question, then how to solve this question means, you know, for those the derived formula is there. For the current drawn for that example, if you take for the series, the current drawn in the series when EMF and N resistance with the internal resistance and also the resistance value is given means, with the series the formula is EMF divided by E by the normal resistance n plus 1 n plus 1. This is applicable if internal resistance and internal resistance, the resistance are equal, then this formula is applicable. If those both are different, then what happens? The given I series is given by Is is equal to E by N capital R plus small r. This is if at all they have given for the different internal resistance and the resistance. In this question they have given the internal resistance and the resistance are same. Same with the parallel, what happens means IP is equal to, if at all those are different values, then for the IP it is EMF divided by R by N plus R. Again, if those both internal resistance and resistance are the same means, the formula for that will be N times E by, that is N times EMF by N plus 1 times the R. Yes. If it is so, in the question what they are asking, you know, the resistance are same, so that asking in the same ratio how much times the parallel is equal to the series resistance. So how to do this, you know, from the question they are given 10 times, right? 10 times the, that is here series, that is R plus R into N plus 1 is equal to N times E by R times the N plus 1. If it is so, from the equation we can say that the N value here will be going to 10. The resistance and parallel with the N value going to be 10. So option C is the correct. I told you in series it will be E by R plus R into N plus 1 if both are equal. If they are not equal means I is, if they are not equal means Is is equal to E by NR plus small r, where small r is the internal resistance and capital R is the resistance. For example, if at all parallel, they are both equal, both values are same means, then E by R by N plus R, right? If at all those both equals are same means Ne by N plus 1 R times. This is how the direct relation to find the how many times the series greater than the parallel. Yes, moving on to the next question. The terminal voltage of the battery whose EMF 10 volt and internal resistance 1 ohm when connected through an external resistance 4 ohm shown in the figure is. Okay. The terminal voltage they are asking, you know. Terminal voltage means V terminal is equal to E by, that is EMF by the normal resistance and internal resistance, that is internal resistance small r. Okay, the EMF they are given, that is 10, and the total resistance which will be 5 here, and also the internal resistance that is given as a 1. So If you substitute those values, then you will be getting value as a 10. Okay. Moving on to the next question. Choose the correct circuit in which achieve the balanced Wheatstone bridge. See, balanced Wheatstone bridge, it's a compulsory question we'll be asking in the next. Okay. How to do this? The balanced Wheatstone bridge formula, it is P by Q is equal to R by S. If this ratio is going to be there, then the answer will be that particular ratio which in these options, this ratio is happening now. That is that we have to find here. In the case A, let me take a 10 by 5 is equal to 10 by 5. Is that only in the quantity I am telling? It is not following the correct relation. For the second option, 10 by 15 is equal to 10 by 5. Again, this ratio is not proper. Again, in the third case, 10 by 15 is equal to 10 by 5. Again, the ratio is not matching. In the fourth case, 10 by 15 is equal to 10 by 5. See, in all these cases, the ratio is not matching. Means that we are not only consider this P by Q is equal to R by R. We have to consider this, they have given the bias, that is forward or reverse bias. If you consider this is that forward or reverse bias, like that means. See, in the first case, which is a reverse bias, then means there is no flow of current. In the second case, there is a flow of current, but the ratio in this case is 1 by 3 is equal to 1 by 2. Right. In the third case, see here, in the third case what happening means, it is also forward bias, that 10 ohm and 15 ohm, that cross link given is matching with the 10 ohm and 5 ohm. So the answer here will be 1 second. Okay. Yes, moving on to the next question. As the temperature increases, electrical resistance is. How to, the temperature increases means the resistance of the conductor increases, but the semiconductor has gone negative value, decreases. Why? Why means the coefficient of resistance, that is alpha value for the resistor for the conductors is a positive. That means if you increase the temperature, the resistance is going to increase. Again, in the second question, for the alpha value for the semiconductor is a negative. That means if you increase the temperature, the semiconductor resistance is going to decrease. Again, inverse relation is also true. So for that, the answer will be, for the conductors, temperature increases means resistance increases. For the semiconductors, temperature increases means resistance decreases. This is what the question is. So from that data, the option is increase for the conductors but decrease for the semiconductors. Yes, moving on to the next question. Two resistors of a resistance 100 ohm and 200 ohm are connected in a parallel in an electrical circuit. The ratio of a thermal energy developed in 100 ohm to that of a 200 ohm is given by. Thermal energy they are asking, energy. In this they are talking about the thermal energy. They have given, they are asking the ratio of thermal energy. What is the thermal energy? That is H is equal to P square by R into T. Right. They are connected in a parallel. Those 100 and 200 are connected in a parallel. How to find the RP value? RP is equal to 100 into 200 by 100 plus 200. So 20,000 by 300. See again on, they have given a clue. If at all, just I will draw the circuit diagram for this question. If it is 100, here it is given 200. Right. They are asking thermal energy development. If at all say the voltage V is here, for the parallel, I told in the chapter of electric potential where the current, which the current IS example if you take and Vs example if you take, in series IS is equal to same in I1, I2, I3, I4 and all. But in parallel, in voltage what happens means the Vs is equal to V1 plus V2, so on. Again, the current in a parallel which will be adding function, that is in parallel I1 plus I2 plus I3. For the voltage, if at all it is in parallel, then the answer will be V1 is equal to V2 is equal to V3, so on. This relation, if you remember, means all the circuit diagrams are based on this relation. If you know this and if you apply perfectly, then the circuit diagrams for you is going to be a cakewalk. Okay. Yes, if we have to apply this to this relation, V is same for both because 100 and 200 are in parallel. So we can say that the voltage for those two is the same. If it is so, they are asking for the heat energy, that is V square by R into T. For that, just to take separately take a value, that is V square is same for both and T is not given any function there, same. So resistance for the first one is 100 and again divided by the ratio asking no. So again V square only and T only, but resistance for the second one is 200. If you take the ratio of these, V square get cancels, T get cancels, 200 numerator and 100 in the denominator. After the taking ratio, the answer will become as a 2:1. Right. This is what this this table, this denotes, this will helps in the entire solving of the circuit diagrams. So answer for this is option A. Yes, moving on to the next question. The match the following question is given and there are 4 formulas are given in terms of the match the following. These are very important. Okay, how to solve this? Yes, firstly in the column A, column 1, drift velocity, electrical resistivity, relaxation period and current density is given. In the column 2, the some formulas are given. We have to find which all functions are for what. We all know drift velocity, that is first drift velocity first I will be solving. So CA Vd is equal to charge into electric field by mass into tau. E tau by m is a formula for the drift velocity. And second comes the electrical resistivity. Electrical resistivity, what is the formula? Electrical resistivity rho is equal to m by n square tau. This is for the electrical resistivity, where tau is a relaxation time and m is the mass. Okay. Next, for the third one, relaxation time, again tau relation they are asking. What is tau relation? Tau is given by same. We know, just make it into numerator, get rho down, then you will be getting m by rho n square. Both are in the inverse relation only. The second and third one are in the n e square, right? Next, D they have given, that is current density. Current density we all know, we can derive it from like J is equal to I by A. Yes, current by area. Then I, the current can be written as NEA into VD, NEA into VD by area. So AA get cancelled here. We left with the NE VD. This option is matching with NE VD. Okay. This is matching with the current density. This is how we have to derive that. Okay. So drift velocity is equal to E tau by m. Current electrical resistivity is a electrical resistivity is rho is equal to m by n square utilization time. So utilization time is given by m by n square rho. But the resistivity given for this E by J. Okay. Yes, moving on to the next question. The effective resistance of a parallel connection that consists of 4 wires of equal length, equal area of cross section. Same material is 0.25 rho, 5 ohm. What will be the effective resistance if they are connected in a series? See, we have given 4 wires, right? 1, 2, 3, 4. They are connected in parallel and of equal length and area of section. Length, area is same for all. What so if they are connected in a series? They have given value of each resistance is 0.25. We know the relation, that is series is equal to 100 times the parallel. From the question 1 we have derived this relation. What is the RP value here from the 0.25 resistance of equal connection? 0.25 values. Okay. RP is equal to 1 by R1 plus 1 by R2. Like that, if you do 4 by 0.25 will be getting, which will be 16, that is 1 by 16 is, comes here. If it will, that is the 1 by 16 means that is the parallel what we get means 1 by 0.25, that is 4 by R, that is for RQ value. Here RP value, RP is equal to 1 by 0.25, 1 by 2.25, like that if you do, then you will get, that is 1 by 0.25 is equal to 4 by R. Then the resistance here comes to the 1 ohm. If you connect the same in the series means what happens, then R equivalent for the series is given by 4R, right? If it is so, they are asking the ratio, it is RS by RP, which will be 4:1. Option B is the correct answer. Yes, moving on to the fifth question. Three resistors having a resistance R1, R2, R3 are connected shown in the given circuit. The ratio I3 by I1 of a current in terms of a resistance used in the circuit is. They are asking ratio I3 by I1. How to do this question? And options you see, all those I1 terms are given in terms of the resistance. You have to get the answers in terms of a resistance. So see, just analyze the circuit. The I1 current going through the R1 and it is in parallel. So in parallel, current will be adding, that is I2 and I3, different current will be going. And again, after that, we will be getting into B circuit. So from this, from the data, that is V is equal to I into R, right, by using the Ohm's law. Because we have to get the answer in terms of the resistance, but we don't know V, we know R2 I1, so V is equal to IR, which is equal to I2 R2 is equal to I3 R3. We don't know V value, so we are finding V in terms of IR. Then I2 will be I3 R3 by R2. This is for the I2 equation. Then keep it like this, and again from the circuit we know I1 is equal to I2 plus I3. As it is in parallel, we have to add the values. This relation keep it as a one equation 1. And next, substitute those values. What if we want to find I1? We know I1, I2 value, then just find I1 value. I2, how can you write this? I2 you can write this as a I3 R3 by R2 plus I3. Going on, you will be getting, that is I1 by I3 is equal to R3 by R2 plus 1. If it is so, they are asking the ratio, right? I1 by I3. I1 by I3 is equal to R3 plus R2 divided by R2. Getting that, they are asking for the ratio I3 by I1. So I3 by I1 is equal to R2 by R3 plus R2. See, in this current electricity, the mathematical solving is more. Usually they will not ask these type of questions. They will ask those technical questions. Okay. Moving on to the next question. Sixth question. Two solid conductors are made up of same material, have a length and same resistance. One of them has a circular cross-section area A1, another has a cross-section area A2. The ratio of A1 and A2 is. Yes. We know the basic relation, that is R is equal to, in terms of L and A, R is equal to rho L by A. That is the resistivity into length and area. This is the basic. From this formula, we can solve all those area relations and length relations. How if at all they convert into NL times, or area is decreased by 10 times. All those such of questions will be solved from this formula. Solve this question. They are telling the cross those have, same material, same length, same resistance. Same material means rho is same, for rho 1 is equal to rho 2, and length is same, that is L1 is equal to L2. Then resistance, that is R1 is equal to R2. Just keep all those values. Example, finally they are asking A1 by A2. A1 by A2 is equal to, how can you write this relation? That is rho 1, rho L by R, right? Rho is same for both, length is same for both, resistance is same for both. So rho L by rho 1 L1 by A1, rho R1 divided by A2, they have given what? That is rho 2 L2 by A2. As from this data we know all those are same. If you can cancel each other, so you will be getting 1 by 1, which will be 1. So A1 A2 are equal. So option is B is the correct answer. Next. Seventh question. The equivalent resistance in AB for a mesh shown in the figure is. The parallel in the circuit, parallel relation and series relations are given. The effective resistance between A and B are given here. We have to find it. So how to find this? How to find this circuit? Terminal A, across A and B they are asking. Just see, 4 and 8 are given here. Above, at this point, they have given 8 and 4 here, right? And there is nothing here. It is like, is nothing but the straight line. They are in a series. So 8 and 4 are in series now. If at all those 8 and 4 are in series means, what is the answer for that? Series they will go into directly add. So 8 plus 4 is a 12 ohm. Next, this 12 ohm and the given 6 ohm, these are in series, sorry parallel, right? If they are in parallel, the RP for 12 and the RP for 12 and 6 will be, it is 1 by 12 plus 1 by 6. That, or else you can say R0 by R1 plus R2, that is 72 by 18, that will be 4. For those 12 and 6, it will be answer is the 4. Next, this 4 ohm resistance and again the what we have find 4 ohm and 8 ohm are in series. So RS series for 4 ohm, 4 ohm and 8 ohm, which can be directly added. So what will be the answer? That is 16 ohm. So the answer is option B. Moving on to the next question. It is 8th question. A charged particle having a drift velocity and electric field has a mobility is. How to find the mobility over here? You know, eighth one. Mobility is given by V, mu is equal to Vd by electric field. So, what is the Vd? If it was what the value is given, that is 7.5 into 10 power minus 4 divided by 3 into 10 power minus 10. So the answer will be 2.5 into 10 power 6, right? And the units they are given, that is meter square per volt per second. So the matching option here is option A. Yes, moving on to the question. The color code of the resistance given below is, they are given color codes, the value of the resistance and tolerance they are asking. See, you know the one shortcut, that is for the remembering this color code, we know it is BB Roy of Great Britain has a very good wife wearing gold silver necklace, right? Gold and silver necklace. If it is so, just write these alphabets from 0 to, start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, until 9. After that it will be 5, 10. Just match those values to the given question. For the yellow color, what will be the numerical given? 4. Next, for a violet color, you know, we, for the brown color, that is the brown color is first one, brown, and this is a black. So it should be 0 for the brown. Next, gold. What is the gold? You know, this gold and silver are having a 5 and 10. So it should be 5. You can write this as a, from according to the concept, that is yellow, violet, brown and gold can be written as 470 ohm. And for the percentage, that is gold and silver, you know, but the gold they are asking, so it should go for 5%. So the option C is the correct answer. Next, moving on to the next question. Which of the following graph represents the variation of a resistivity with the temperature is given here? So how variation of resistivity temperature takes place here means, that is asked for the copper. This is directly remembering question. They can ask for the copper, semiconductor, conductors, nichrome, like that. For the copper, the graph for the resistivity, which is a metal, right? As you increase the temperature, the resistivity of the will be going to increase. So, the coefficient of the resistivity will have some value at a temperature 0. At 0 temperature also there is a resistivity value for the copper. So there is no there is intercept is here. This intercept denotes that. So the correct answer is option B. Moving on to the next question. Which of the following acts as a circuit protection device? Circuit protection device. If at all the circuit is there, how you will protect in a practical case? That is option A inductor, option B switch, option C fuse, option D conductor. You all know the fuse which are used in households. In the house, the fuse are maintained. Fuse are the value is it helps in the preventing an excess amount of current to flow in the circuit or from the short circuiting. If at all excess current is flowing in the circuit means which will prevent that. How it will prevent means the fuse that are made of a low melting point and low resistivity. If the current is going on high means the temperature going to increase there. If at all temperature increase means the melting point that is made up of the low melting point conductors which will make the fuse will going to melt. If this going to melt means the circuit, if at all, example, believe this as a fuse, this is made of the low melting point. If current is going like this, if at all heavy current is going means the melting point, the temperature increases, and also they are given a low resistivity. If at all the low resistivity means it cannot withstand much temperature. So this will going to melt. If it melts means, if it going to melt means there is a gap between these two current flowing circuit. If there is a gap means there is no flow of a current circuit, it suddenly stops it, which will prevent damage of the entire those equipments, electrical equipments. That is why fuse which are easily available, cheap and best to use to prevent the excess flow of current and protect the devices. Next is the 12th question. In the circuit shown below, the reading of the voltmeter and ammeter will be. They have shown two circuits. They are asking for the reading of the ammeter and voltmeter. In the circuit 1, in the circuit 1, ammeter is A1 given, voltmeter is V1 given. From the circuit 1, they have given a resistance, okay. They have given a voltage, so we have to find the current value. So I1 is equal to V by R, which will be 10 by 10, which will be 1, right? The current from the first is 1 ampere. Again, in the same, what is the V1 value? That is voltage reading value. V1 is equal to I1 into R1. What is the I1? 1. What is the resistance? That is 10, which will be 10 volts. From this, the ammeter will reading the 1 ampere means the voltmeter reads the 10 volt. Again, in the second circuit, see here, voltmeter is connected here into this 10 ohm resistance and ammeter connected across the same as in the first case. In this, they have given a resistance, they have given a voltage, we have to find the again current. That is I2. I2 is equal to V2 by R2. V2 by R2. What is the voltage they have given? This voltmeter is connected to this resistance only. They are not connected for this above resistance. So again you can take, that is the value given 10 and resistance that is connected for this only, so 10 ohm, which will be 1 ampere. Then what is the V2 value? This is V value, okay. What is the V2 value? V2 is equal to I2 into R, that is I2 given, that is 1 ampere. What is the resistance they are given? Again, the V2 connected is a 10 ohm, so 10, which will be 10 volt. From the all those two circuits, we got 10 volt, here the 10 volt. So we can say that from the options V1 is equal to V2 and I1 is equal to I2. For that option will be D. Next, 41st question. The energy that will be ideally radiated by a 100 watt transmitter is energy that is radiated is. What is the energy given here? It is energy we can, the data given here is a power they are given. Watt means which is the SI unit of a power, right? And the time is given here. It is 1 hour, which can be written as a 60 minutes, right? 1 hour has 60 minutes with a 60 multiplication giving a second value, that is a 3600 seconds, right? If it is so, they are asking for the energy. Energy, we can write it as a, that is heat energy, it is a P into T, right? Power, power multiplies the T. So, they are given 100 into 10 power 3, that is K value into time 3600. For this, the answer comes, we have a 10 power 5 plus 10 power 2, that is 10 power 7 into 36, that is 36. So, we know the answer will be option 4. Next, 42nd question. 6 similar bulbs are connected as shown in the figure with a DC source, EMF E, 0 internal resistance. The ratio of a power consumption by the bulbs when all are glowing and second in a situation when 2 from section A and 1 from section B are glowing. The case 1 is all are glowing, that is all the 6 bulbs are glowing. In the second case they are given in the second 2 from the section A and 2 from the section A and 1 from the section B. See, why, what, we know all in terms of a radius how the resistance for a parallel series calculation. What if they give bulb? Say, bulb also having some resistance. So, there is nothing separate relations going here. For the bulb, for asking me, just consider the bulb which having a resistance R. All those bulbs having a resistance R. So, there is the term only different, like a bulb. But they indirectly telling it is a resistance, okay? Then see, if at all these values having the same, that is resistance R, if it is so, then you all come to know that here those are 3 circuits in a parallel. That is, if you consider this as a common point, those 3 are in the parallel. So, how to do this? That is, this RA, which can be written as a 1 by R plus 1 by R plus 1 by R, which will be 3 by R. Again, 1 by Ra is equal to 3 by R, Ra is equal to R by 3, right? Again, Rb, if you calculate the same, that is 1 by Rb is equal to 1 by R plus 1 by R plus 1 by R, which will be 3 by R. For if you inverse the relation, that is Rb is equal to again R by 3. Then if you equivalent that, there is these R by 3 and the R by 3 will be in a series. If it is so, then directly add them. There is R by 3 plus R by 3. LCM is 3 common there. Above it is a 2R by 3, right? It will be 2R by 3. In the second case, they are telling in the RA there are 2 resistance are present and the RB is a 1 resistance. Again in a parallel, in the second case, RP of A series can be given by, that is 1 by R plus 1 by R, which will be 2 by R, which can be written as R by 2. Right? Again, in this R by 2 and another resistance in the B circuit, that is R, are in the series. So, what is the value? Take LCM, that is How to find this series? R by 2 plus R, which will be, take LCM, then you will be getting, it is a 3R by 2, right? That will be 3R by 2. Finally, what they are asking, power consumed by this circuit ratio. There is power consumed in the first and power consumed in the second. Power value, that is P square by R. So what is the answer here? There is a voltage, what they have given. Huh? How to find the voltage here and all. See, again, this for above P1, this is V square by R is for the second case. That is, you can write this as a E square by R equivalent. Then you can write this as a 2E square by 3R. Right. If it is so, then we can write the P1 by P2 as a 3E square by 2R into 3R by, so which will be cancelling, see, cancel what and all get cancelled. 9 by 4 will be left. E square get cancelled, R get cancelled. So the ratio will be 2, 4. This is how the question gonna solve. Questions are common in NEET, okay? We can ask these type of questions. Yes, moving on to the next question. For the circuit shown in the figure, the current I will be. What is the current I will be? See, just analyze the circuit, what they have given. They have given a resistance that is 1 ohm and 4 ohm. But they have given that is no voltage also they have given, but they have not given any current value. Okay. Can't you guess this? Can we solve by the Kirchhoff voltage law? For the circuits, we have to apply the Kirchhoff voltage law. See here, I is going in this direction, right? If it is so, by KVL, we can write this as in the direction we can write as a positive value for the current. So 4I, right? Again in this direction only. So we can write this as 1I. Again, see in the EMF there is cells, what happens means this denotes a negative load, this denotes a positive. If current is flowing in this direction means then I can be written in a positive way. If the current is flowing from this direction means that is I can be written as negative. In this case the current is flowing from the here like this from left side. In this the current is flowing, in this way current is flowing. So we can write this as a negative value of the voltage. Again in the same direction of the current for the resistance, so plus 1I. Again in that voltage from cathode to anode, so we can write as a negative. So what is that we are getting? What are the common here? There is a 4I plus 1I plus 1I, which will be 6I, minus 4 minus 2, which will be minus 6 is equal to 0. So 6I is equal to 6, for that I is equal to 1. Then it is answer. I think you all get that. By Kirchhoff voltage law, what happens means when you take this special case, in this special case, if you go, if the current is flowing from the cathode, is going from the anode to the cathode, then the voltage can be written in the positive way. So from that, take a point and reach that point again. That will be the answer. Okay. The same next question, 67th, which is based on the 66th concept only. The circuit given below, Kirchhoff's rules for the loop BC C, D, E, B given by. Okay. Option in terms of equations are given. There is no calculations. Just write the proper equation. We will be getting the answer. See, let's as in the option we have started from the I2 value. Here they have started from here. So just write on the equations there. The direction is the same. The direction is in terms of the current. So positive value for that. So just write this I2 R2. Okay. I have told if at all there is a positive first means we have to get the positive value of the voltage. So we can write that as U. Again if you go here there is a negative is coming, so minus that is V3. Again if you go in this direction, see you can write this as a from positive, but the direction I3 here coming in the reverse direction. I have told if it is in the direction of current, then resistance will be positive. If at all it is in the opposite to the direction of the current, means the resistance is going to be negative. So you can write this as a I3 into R1. So all are equal to the 0. Then what equation hold good for this? Which equation? That is, just see, I think it's option B. Just check it. I2 R2 plus E2 minus E1 E3 minus I3 R. There is R1 is equal to 0. This is a correct. See, I will repeat that same concept. That is, remember this. I will take separately here. See, I will make a box for it. Is what for resistance, what for voltage. If current is in this direction, what happens? If I is in this direction, sign of V is. If I is in this direction means from positive it is going to negative. From positive to negative it is going means in the same direction, that then V is given as a positive. If it is reversed, then reverse value, then V is a negative. Again I will in terms of resistance I am going to do in the direction I and R. We are considering in this direction and also current is in the same direction, then the IR value will be positive. If you consider in the reverse direction but current is flowing in this direction, means IR is given as the negative. If you remember this topic, the whatever circuit questions they will ask, you will solve it very easily with your fingertips. Okay. Next, moving on to the next question, that is 68th question, which is somewhat a bigger. This type of questions will not ask, but I have taken this for the concepts based. Okay. It's actually 2019 Odisha question. Let's say in this circuit current I is flowing here, which divides here because it is parallel. Current divides. This will be given as I1N, which can be write as I1 and below it is I2. Okay. Yes. How to tackle this type of question? Just find the equivalent resistance there. This I1 circuit, that is in parallel. Again, below it is in parallel. Both are in a parallel to each other, but 20 30 are in series. So, if it is so, R equivalent is equal to above. It is a series 30 plus 20, which will be 50, and again below which is 50. Now these both are in parallel, so you can write as a 1 by 50 plus 1 by 50, right? If it is so, you can write as a 50 as a LCM about 2 by 50, which will be 1 by 25. 1 by 25 is R, 1 by R equivalent to value. If that is If they are asking for R equal means the answer will be, sorry, 2 by 25, 1 by 50. Okay. No, 2 by 50. So R equal is equal to 25. Right. 2 by 50. We found the R equivalent. Then just find the current. I is equal to V by R. It will be the resistance we know again 25 and the voltage they are given as 12. It will be 2 by 25 ampere. And next, as the resistance of the two branch is same, why? Because above this I1 flowing is also 50 and below I2 is flowing also 50. If at all there is same means the current across the series is same. Across the series both are giving a value of 50-50. So I can write it is R is same. So I can say I1 and I2 are also same because summation there is RA is equal to R df, right? From that I can say I1 is equal to I2, which again is equal to 1 by 25 ampere. Then they are asking voltage question, that is V1 is equal to, I know, I1 R1, that is I1 1 by 25 into R1, that is 20. So which will be 4 by 5. For the V2 case, which can be written as I2 R2, which will be 1 by 25 into, that is in the below case, that is U and 30, which will be 6 by 5. So overall voltmeter reading they are asking. Voltmeter reading can be given as voltmeter reading can be written as a V2 minus V1, which will be 30 by 25 minus 20 by 25, which will be 10 by 25. You can write this as a, it is a 2 by 5. You can write 2 by 5 means 20 by 5 point, so you can write as a 0.4 after dividing that. This is what voltage reading is. I think you all get all basics are compiling here, all basics are applying here, only basics here. Just apply those at a correct time, as a logic, just use the logic, then you will be getting the answers. Yes, we have discussed that question, that is 69th in the first question only. And moving on to the fourth question. By seeing, you can say that this is based on the Wheatstone bridge. They are asking a Wheatstone bridge is used to determine the value of the unknown resistance X by adjusting the variable resistance Y as shown in the figure. For the most precise measurement of X, the resistance P and Q. This is the 94th question, right? They are asking most precise value. How to find this most precise value? For the most precise measurement of an unknown resistance X, the resistance P and Q should be approximately equal and should be small so that it could decrease the error in the experiment. You all know how to decrease the error. If you want to decrease the error means the P and Q value both must be same, and lesser the quantity of them will give the lesser error. That means should be approximately equal and are small. Moving on to next question, that is 95th question. Okay, the potentiometer circuit has 1.5 volt balance point at 36 centimeter, and another one, that is 1.5 volt replace the first cell. Then at what length of the wire the balance point occurs? They are replacing the they are replacing the EMF. How to find? Potential gradient from the potentiometer. Potential gradient E by L, that is EMF by length of wire. means they are directly proportional. That means directly proportional means E1 by L1 is equal to E2 by L2. If it is so, we know E1 value. What is the length of the first one? That is 36 is equal to what is the E2 value? That is 2.5. They are asking this length only. How to get that? Cross multiply it. Then we can say L is equal to 2.5 into 36. 2.5 into 36 divided by 1.5. 2.5 by 1.5 can be written as 5 by 3 into 36, which will be 12. That means the balancing point will be 60 centimeter. The main relation is potential gradient is given by E by L, where E is directly proportional to L. That is means E1 by L1 is equal to E2 by L2. Yes, this is all the current electricity chapter. Discuss all type of questions from this chapter, and expected questions from this chapter are 3. So prepare well this for this chapter. Okay. Yes. Next chapter will be discussed in the next session, that is moving charges and magnetism. Yes, sir. We hope you are preparing well for the 2025 paper. All the best.